Okay, so, oh Lord, I am so distracted. My dog is eating a plastic wrapper, and every time I try to get it from her, she runs away. So I've just given up, but it is so distracting. I'm sorry if you hear it. Um, so I'm going to show you how to do this on StatCrunch. Um, the only thing that you need to know about StatCrunch is what information they're going to put out, what information they're going to ask you for. And sometimes it's given, and sometimes it has to be calculated. Seriously, stop. Give me that. I can't take it. Let me see. Let me see. Thank you. Thank you. Okay, get down. Um, so let's just go to StatCrunch and let me show you. Um, I forgot where StatCrunch is. I'm so tired, y'all. Here we go. Here's StatCrunch. Here's StatCrunch. Here is StatCrunch. Okay. So we're still doing confidence intervals. So it's basically the same situation. You're going to go to stats, and this is where we go when we know the standard deviation of the population. This is where we go when we know the standard deviation of the sample. And this is where we go when we're working with proportions. And proportions are usually those percentages. Okay, so we choose this option. Again, we're only doing one sample. We don't do two sample in this course. And again, we're going over to do it with the summary because we don't actually have the results of the survey. We don't have the 800 pieces of data. We only have the summary of those 800 pieces of data. So we're going to click that. And here you need to know that the number of successes, they want to know how many people said television, not what the percentage is, but how many people said television. Well, they did not provide us with that information, but we have already calculated it. So if this is the formula, right here, we find the value of p hat, which was given as 0.27. If that's found by taking the number of people who answered television and dividing it by the total number of people asked, which is 800, then the way you calculate this right here is to multiply 800 times 0.27. But haven't we already done that right here? We certainly did. So we've already answered or obtained the value of n when you made sure that it was going to produce a normal distribution. So we already know that the number of people who answered television was how they got their news. Out of the 800 people that was asked was 216. So on StatCrunch, we're going to enter the number 216 right here. And the number of observations, that was how many people were in the survey, was 800. We're doing a confidence interval. This time they want 99% confidence interval, and we are always going to choose this first method, standard and MALD. Again, this is just a different method, and it's for another course. We're not going to do that one. We're going to choose standard and MALD. If you want to see the plot of the number line, you can do that. I don't like storing it in the data table, so I'm just going to do compute. And when we do compute, we get the left limit and the upper limit. So I'm sorry, the lower limit and the upper limit. So the lower limit is 0.229. You round that up to 2 decimal places, it's 0.23. And if you remember what we wrote down 0.23. And then here we wrote down 0.31. And if we go back and look at StatCrunch, we see that the upper limit is 0.31. So you can use StatCrunch to get the lower limit and the upper limit of your interval. And then if you have the upper limit and the lower limit, you subtract the 0.27 from it to get the margin of error. So 0.31 minus 0.27 would give you the 0.04, or you could say 0.27 minus 0.23 to get the 0.04. So that's how you can do it using StatCrunch. Since I've already got that on here, let's just go ahead and do this one real quick. We'll do stat crunch on this one. And then I will do one more showing how to do it on the calculator. But you can probably figure it out on the calculator, but I'm still going to show you. Okay, so in a survey of 1,000, so what is that? That is the number of people in my survey. It's my sample size. 1,000 people. 490 opposed, allowing transgender students to use the bathroom of the opposite biological sex. So 490 said no. 490 basically said no. And so since that's what they're going to, I think that's probably what they're going to ask us for. Construct a 90% confidence interval for the population proportion of US who oppose. That's what they want to know. They want to know who said no. How many of the entire population? So what they're saying is, okay, so if 490 out of 1,000 said no, how many out of all US adults would say no? So we're using this sample to make a prediction about the proportion. That's why this is a confidence interval. We're using sample to make a prediction about the population. So this right here is our p hat. Our p hat is the proportion of the sample. So we're interested in who said no. So that's 490 out of 1,000. Okay, you do that division, 490 divided by 1,000, and you get the value of your proportion. 490 divided by 1,000. And that was 0.49. Now, if you're wondering why we didn't do that last time, because last time they gave us the proportion, they gave us the percentage. So p hat was just given to us. This time we had to calculate it. So, and this time we see that 490 is the value of our X. Remember, because that's how many we're interested in. X is 490. Since that number is a number bigger than 5, when you do p hat times n, that is what we just did. 490 times 1,000, you get 490. So this is our X, the number of people that said no. That is our X value. So our X value is greater than 5. Since our X value is greater than 5, that's good. Our Q, remember, also has to be greater than 5. And if there was 1,000 people and 490 said no, then how many people said yes? Or if 0.49 is the proportion of the people that said no, then that means that 0.51 of them said yes. So that would be 510. Okay, so we've got our X value, we've got our N value, we've got our confidence interval. They want a 90%. And I believe that's everything we need for StatCrunch. So I'm going to run over here to StatCrunch. I'm going to do Stat, choose the Stat drop-down menu. I'm going to go to Proportion. It's always going to be one sample in this class. We don't do two samples in this class. And we're working with summary data. Why? Because we did not see the 1,000 pieces of data that was a result from that survey. How many people said no? 490 out of 1,000. And this is a confidence interval. It's a 90% confidence interval. And we're going to use standard walled. And we're going to do compute. And it shows us that our lower limit and our upper limit. Our lower limit is 0.46. Don't round that 6 up because 3 is smaller than 5. And 0.52. So 0.46 and 0.52. Jot that down on your paper, and we will run over here. And we saw that these were both greater than 5, so we knew it was going to be normal. And since our p hat was right here at 0.49, 90% confidence interval is in here. This is 90% confidence interval. Our margin of error we'll calculate here in just a second, but we said that the upper limit was 0.52 and the lower limit was 0.46. So I believe you can see that the margin of error was 0.03. So if you take 0.49 and say plus 0.03, you'll get the 0.52. Take 0.49 and subtract the lower end from it, and you get 0.03. So we added 0.03 on this side and we subtract 0.03 on that side. So the margin of error is 0.03. Just in case they ask you what the critical value was, the critical value would be the z-score that we would need for a 90% confidence interval. Where are you going to find that? You're going to find that right here. There's the z-score for a 90% confidence interval. Why are we using a z-score? Because that's what you do with proportions. So your critical value is 1.645. So your critical value is 1.645. We got that right off the table. Yes. You can use your calculator to get that value also. I'll show you how to do that on the calculator video. And you could calculate the margin of error by using the formula. And the formula for the margin of error says your confidence, your critical value, which is 1.645, times the square root of your p hat, which is 0.49, times your q hat, which is 0.51, divided by your sample size. So if you do that on your calculator, you end up with the same thing that we got over here, 0.03, which was your margin of error. Okay, so I'm going to stop this one and do a calculator video, and then I will work this last one, which is calculating a sample size. Okay.